Good evening, friends. Welcome to Sea Taking Education. My name is Rona Kapoor and I am your trainer for the day. The basis of all quantitative ability is the number systems. Before going to number systems, let us discuss something about quant. All the aspirants of the MBA entrance aptitude exams have this general notion of the quant. They always feel that quant is very difficult and they are somehow not familiar with quant. Let me tell you, quant is the easiest subject and it is all about the basics that you have ever learned in your school life. All the subjects like time space distance, geometry, everything has been taught to you in your basic classes from 8th to 10th. So all these chapters are very basic. So my first advice to you before beginning this slide, please remove the fear of quant from your minds. In this video we'll discuss only the introduction of number systems. Number systems. What is number systems? Number systems have been in the existence since past several thousands of years. In fact, the very beginning of number systems is still unknown. Before the number systems like the counting numbers 1, 2, 3 were available, what the prehistoric man used to do was, for counting their cattle, they used to use stones. One stone represented one animal, second stone represented second animal. So they didn't know the exact counting numbers of 1, 2 and 3, but they had a counting system with the help of these small pebbles. Slowly and gradually, the number systems came into existence. The very basics, at the very basic level, they started with the natural numbers. Natural numbers are the numbers starting from 1, 2 and 3. And it goes up to infinity. But the problem with number system was, at that point of time we didn't have the number called 0. It came into existence in the Gupta era when Aryabhatta discovered that. So the problem was that we could count only till up to very small numbers. We had 1 to 9 only, and the calculation of higher numbers in several thousands was practically impossible. So when Aryabhatta came up with 0, the initial notion was that if I have one fruit, one apple, it was called one apple. If I had two apples, it was called two apples. But what will happen if I don't have any apple? So that was where the beginning of 0 started, because some number should represent nothing. So that's the point where the 0 came into existence. Natural numbers, that is all the counting numbers from 1 to infinity along with 0, becomes whole numbers. Now when 0 to infinity was available on the positive side, there was a need felt for the numbers to exist even on the negative side. For example, if I have to I have to give money to you. If I have to give 5 rupees to you, call it plus 5. But for your receiving end, when you are receiving the money, you will say that my balance is minus 5. So this need on the other side was needed for the negative numbers also. This gave birth to integers. Integers are the negative numbers, 0 and positive numbers. 0, as we know, is neither positive nor negative. It comes in between. It represents nothing, neither receiving of the money nor neither taking end of the money. Now let us dwell into what is even numbers and odd numbers. The numbers ending with 0, 2, 4, 6 and 8, these numbers are called even numbers. Even numbers because these numbers are multiples of 2. We know the table of 2, 2, 4, 6, 8. These numbers are even numbers. And other numbers that are odd numbers are the numbers ending with 1, 3, 5, 7 and 9. These numbers are called odd numbers because they are not multiple of 2. Even numbers and odd numbers will be your basic classification that will help you always throughout your quant. And other classification that we have done is prime numbers and composite numbers. Prime numbers are the numbers which are multiple of 1 and itself. In other terms, this is the basic definition, but for making it simpler to understand, these are the numbers which won't occur in any table. The numbers like 7 does not occur in any of the tables. Number like 5, 3 and going higher, the numbers like 13 and 19 don't occur in any table of any lower number. 19 occurs only in the table of 1 and 19, that is 19 into 1 and 1 into 19. So these numbers are called prime numbers. Composite numbers on the other hand are the numbers which will appear in some or the other table besides 1. For example, let us consider 10. 10 comes in the table of 1, 10, and besides that it comes in the table of 2 as well as 5. So this becomes a composite number. When we start the prime numbers starts from 2, 3, 5 and 7. Now let me tell you the importance of these 2, 3, 5 and 7. First of all, 1. The 1 being the basis of calculation, it is considered as neither prime nor composite. We always say that 1 is neither prime nor composite because it is the reference number that we take. The first prime number that comes into picture is 2. 2 does not appear in, obviously between 1 and 2 there is no number, so 2 won't appear in any of the tables. So 2 is the first prime number. And noticeable thing over here is 2 is also the only even prime number, because starting after 2 all the even numbers will appear in the table of 2, right? Because if we consider 2, 4, 6, 8, all the other numbers besides 2, 4, 6, 8 will appear in the table of 2. They can never be prime numbers. Similarly, 3, 5, 7 are prime numbers, but 9 is not. 9 will appear in table of 3. And then 11 is the prime number, 13 is the prime number, then 15 is not. 15 appears in 1 and 15 as well as 3 and 5. Going so on and so forth, we will be able to differentiate between prime numbers and composite numbers. Now let us consider the integer part. Here we have got a classification named integer. Integers are divided into positive numbers, negative numbers, non-negative numbers and non-positive numbers. Now let us understand the basic classification. Positive numbers means all the positive numbers. Positive numbers won't include 0 because it is neither positive nor negative, and also not negative. So the positive numbers will start from 1, 2, 3 and infinity. Similarly, negative numbers will begin from -1, -2, -3 and will go till negative infinity. Now consider the non-negative numbers. Non-negative numbers are a classification which for the numbers which are not negative. In the sense, the number 0 is not negative and the number 1, 2, 3, the positive numbers are not negative. So we have to just from the entire range of integers we have to remove the negative numbers and all the other numbers are non-negative. The basic difference if we take over here between the positive number and non-negative numbers is 0 appears over here. See, you can notice that 0 is there and over here the 0 is not there. So these numbers are starting from 1 and these numbers will be starting from 0. This is the very basic level, okay? And now we have done all the rational numbers. Now we must understand rational numbers and irrational numbers. What is the basic difference of rational numbers and irrational numbers? Rational numbers are the numbers which can be expressed in terms of fractions. For example, if I consider 4 upon 2, that fraction would give me result 2, right? Then if I consider 4 upon 5 will give me answer 0.8. All these decimal numbers are coming to an end. Another example if I have to take is 2 upon 4, that would be 0.1 upon 2, 0.5. This number is coming to an end. And in other terms, if I consider 2 upon 3, it would be 0.666666 and it would be recurring. When the number is recurring, we term it as rational numbers. On the other hand, in irrational numbers, the decimal place does not end ever. The supercomputers have calculated up to 5 lakh digits, but the end of the decimal places have not been found out yet. So the numbers like √3, √2, √3, √5 and pi, all these numbers are irrational numbers. We have calculated up to n decimals, but these numbers are neither ending at a finite value, neither it is recurring at any point of time. So the numbers like 0.8, 0.25, 0.345, they are ending somewhere. But these numbers like √2, √3, √5, √7, all these numbers will keep on going on up till infinity. Also, a noticeable thing over here is when we consider that √2 into √3, if we multiply two rational numbers, the result will be a rational number. And also if we add two rational numbers, the result will be a rational number. Why? Because all the decimal places which are never ending, when they'll go on adding, we won't get any decimal places at infinity, even at infinity, because all those numbers will go on adding. Also in other example, if we add 2 plus √3, we know that 2 plus root 3, it is 2.00000, and root 3 is 1.73 something something, and it will go on till infinity. So the resultant value will be 2.13 something, and the final decimal places will go up till infinity. So this is the basis of rational numbers and irrational numbers. Coming up to the basic classification, to the main classification, that is real numbers and imaginary numbers. Now let us discuss what is a real number and what is imaginary numbers. Real numbers are the numbers which you can actually use for calculating, and you can actually use for the counting of things, whereas imaginary numbers appear mostly in engineering applications. Most of the engineers, if you are an engineer, you must have learned Laplace transform, Fourier transform. They are all based on imaginary numbers. Let us consider the one example: 2 square. 2 square is 4, as well as minus 2 square is 4. Meaning that if we take squares of a positive number or a negative number, the root has to remain, the root will be positive. But what if in some cases we get square root of minus 4? We all know that if it is a square, it has to be positive. But in certain applications, in certain cases, we get a negative square root of negative number. So that is termed as, that square root of minus 1 is termed as the term I. All these terms, when the term I appears into picture, it is called an imaginary number. Because in practical existence, the negative perfect square can never occur. So that's why this term is definitely imaginary. So we have named that as an imaginary number. All these numbers, real numbers plus imaginary numbers, are totally in a sum called number systems. Going down by the hierarchy now, we first went up, now we'll come down. Numbers are divided into two parts, that is imaginary numbers and real numbers. Real numbers are further divided into two parts, that is rational numbers and irrational numbers. Again, natural numbers are divided into three categories. First as integers. Then all these integers, negative to positive, it has got a subset, that is whole numbers, 0 to infinity, 0 to positive infinity, and if we remove 0, that is natural numbers, and natural numbers will be further divided into even, odd, prime and composite. Understanding the basic concepts of even, odd and prime composite will be very much beneficial for you of your quantitative ability in the entire number systems. Thank you. Thanks for being with CTking.